In this problem, we're multiplying square roots. In other words, we're taking this root, multiplying it by itself. So really what that means is taking the square root of 2 and we're squaring it. And then we're doing the same thing here. We're taking the square root of 3 and squaring that. Here we're taking the square root of 4 and squaring that. And then the last problem, we're taking the square root of 5 and squaring that. Now squaring and roots are inverse operations. But before I go further talking about that, let's use this simple example to understand what's going to happen in these tougher examples. Well, let's solve this, right? We have the square root of 4 times the square root of 4. What is the square root of 4? Well, it's 2, okay? And this is 2. So this really is equal to 2 times 2, and that's 4. And if you think about what's happening here, if we had a square, you're saying the square root is 4, the square root of 4 times the square root of 4. So that means you're taking two side lengths, square root of 4 times the square root of 4, multiplying them. The area should be 2 times 2, or 4. So basically, we're squaring the square roots. And notice that what happened was, we took the square root of 4 times the square root of 4, and our answer was just 4. So in general, you can say that the square root of a times the square root of any other number a is always going to equal a. Why? Because, well, we're squaring the root. Squares and square roots are inverses. So that means that in each of these, I hope that's making sense, the square root of 3 squared is just 3, the square root of 2 squared is 2, and the square root of 5 squared is 5. Now in other videos I'll try to get more in depth into this, but this is such a useful rule that I had to share this problem.